Sorry, we are starting again in Chapter 2, Boolean Operators, the big high-level overview that we started last time. It is slide 22 if you're looking at the PDFs of the slide. Otherwise, if you've got the Keynote Live, it should be on Boolean Operators. So, what we've covered so far is the basic language of writing a statement and what a statement is composed of, what it looks like in Java, the use of the mathematic symbols and the semicolon and the assignment operator. And that's enough to write a simple program which would execute statement after statement after statement after statement to get something done. The next step in programming is to use logic to control which statements get executed. And we do that using logical conditions, and those are composed of logical values, trues and falses, and Boolean operators, which are listed here in the table. So you can combine values and operators and Boolean literals to figure out if something has happened yet, or is about to happen, or is never going to happen, and then execute the correct code based on what the result of the Boolean expression is. The result of a Boolean expression is always, let me move forward, a true or false. It always boils down to a true or a false. So any complex logical condition that you look at, if it's compiles and is written properly, it will evaluate down to a true or a false. And then we can use if-then statements or looping statements to control the flow of execution so that it isn't just purely kind of top-down step by step, but it can jump around. The Boolean operators in the table are just the basic Boolean operators as they appear in Java. Sorry, I'm jumping back to that slide just because I wanted to just real quickly say these may not entirely be, they're not consistent necessarily with every other language, and there's some places where I feel like I wish it wasn't the operator. Like for instance, the logical AND is this double ampersand, and the logical OR is this double vertical pipe. Why isn't it the keyword AND the keyword OR? I don't know. So sometimes I feel like I should be apologizing for it as if it's my responsibility, but it's not. But it is what it is, and you do get used to it fairly quickly. Okay, so just as a running example in the chapter, I say we've got this recipe. We're creating a beverage, and one of the steps is to boil the mixture, and you have to boil it for 90 minutes. So, key idea here is that if our program was running and controlling some sort of an industrial kitchen process, we would need to have a timer going, and we would need to keep track of the value on the timer, and we would need to obviously stop the boiling when we hit whatever the preset time is, and the recipe is 90 minutes, I believe. So we could ask a question using Boolean logic just to see if the boil timer, if that's counting in minutes, is greater than or equal to 90. So that would be what's called a Boolean test or a Boolean condition. It would evaluate to a true or a false. Either the boil timer is greater than or equal to 90 or it's not. There's no and there's no fuzzy logic here. It either is or it isn't. The result is a true or a false. And then that will be used to drive what happens in the program. So we do it two ways. One with something like an if-then statement, which is common to all programming languages. The syntax is a little different maybe in Java. So the syntax requires, well, the keyword if, lowercase I, it can't be uppercase. You have to have these parentheses. So after the if, there's an open parentheses, and at the end there's a closed parenthesis. Inside is the Boolean test or the Boolean condition that will evaluate down to a true or false. And then for most if statements, you're going to use an open curly brace and a closed curly brace to surround the statements that you want executed for a true condition. So if the test is true, you'll execute those statements in between the curly braces. So it could look something, this is completely made up, a completely made up method, but I assume maybe if you do actually have a programmed industrial process like this, that you have methods that you call to turn certain things on and off. And if you had a method like do shut off stove, and you wanted to call it when the boil timer hit 90, you would write it something like this. If boil timer is greater than or equal to 90, open brace, do shut off stove, which just calls this fictitious method, and then close brace. The other common thing we do with Boolean logic is repetition, which is to do something repeatedly, over and over again. Looping is it's sometimes called. Java has the three common looping structures you've probably used and learned in a previous language, and we'll go over them in detail. What I've got here is an example of a while loop. So I'm assuming that the recipe calls for the mixture in the industrial pot to be stirred during the boil time. So if we want to stir the pot and assume we have a method set up called stir the pot, again, completely fictitious, made up, just to give you an example of the syntax, you could write this stirring code something like this: while not, the exclamation point is not, boil timer greater than or equal to 90. So that just says if the boil timer is not greater than or equal to 90, stir the pot, which is consistent with what the recipe asks for. That is, until the boil timer expires, keep stirring the pot. Call that method stir the pot over and over and over again. Again, we've got an entire chapter on Boolean logic, if-then statements, and repetition structures coming up in a bit. Like I said, there's a ton of built-in methods in Java. We will frequently use them using what's called an object.method syntax, which is we'll address an object that we've created in our program and then use a period or a dot to access methods that are built into that object. Just as an example of one we'll be using in Chapter 3, we're going to create a button which comes from the JButton class. We're going to call it OKButton, but we're going to disable it so that it can't be pressed until something else happens on screen. So the syntax is object, which is OKButton, dot, method name, which is set enabled. That's a real method, and you pass it a real Boolean value or conditional statement. So this is now not a fictional method. That is a method that's built in, and I'll show you how to use your IDE to learn more about the built-in methods in Chapter 3. The other thing is you can make your own methods. That's to some extent the power of most programming languages, is to take code that you've written and tested and works, and that you know you'll need to use multiple times during the running of a program, and to move it into a named method that you can call or invoke anytime you want to run that code. So we talked about this a little bit last time, but these are in object-oriented languages, these are generally referred to as methods, but there are other names, and if you learn BASIC, some form of BASIC, they're called functions. If you learn other languages, they're procedures or routines or subroutines, and there are even some other odder names that I've seen over the years. Java refers to these as methods. If you took the mobile development course, Lua refers to these as functions. And the syntax is slightly different than maybe what you're used to, but the real key is to be able to write your own methods and then call them when you need to. And we'll cover this in detail in Chapter 9, but I just wanted to give you just a little example, again, a taste of the syntax, so that when we get to Chapter 9, maybe it's a little bit of a little bit more familiar to you. So this is pretty much a worthless method. I needed to find something that would fit on one slide, not be overwhelmingly complex, and illustrate the key features of a method. So we previously had to do this little bit of math where we were converting from pounds to kilograms. We had to multiply by 2.2. Let's say you just have to do this a lot and you don't like typing the asterisk. Maybe, I'm not sure, but you don't want to do the math. Rather, you want to write a method to do the math for you. So what you're seeing on screen, double convertToPounds, is a valid Java method. Its name is convertToPounds. It does a calculation based on data that it receives. So it receives a decimal value as a parameter, and then it multiplies that decimal value by 2.205, which is just slightly more more accurate a conversion. It assigns the result of that into a variable called value, and then it returns that value as a double decimal number. There are a number of advantages to using methods, including reducing repetition in your code, duplication in your code, redundancy in your code. Redundancy, places in your code where you do the exact same thing as you've maybe even cut and pasted it from multiple locations, is a way to attract bugs. So we do try to not cut and paste as much as possible. To call the method, again, you need to know the method name. It was convertToPounds. So to do that same calculation we had earlier in this slide that we broke that statement up into its little constituent elements. We had two values in kilograms. We needed to convert them to pounds. We needed to add them together and convert them to pounds. If you wanted to use this new convertToPounds method instead of actually doing the math yourself, it would look something like this. You call convertToPounds, you send it the values in kilograms that you need to convert. Here I'm adding them together to get a total kilograms, and it will do the conversion, that is multiply by 2.205, and then send that decimal result back and store it in this variable pounds of DME. Again, we have an entire chapter set up to look at creating your own methods, what the syntax variations are and the design kind of ideas are to make it useful. That is the end of the big high-level overview. I want to stress that this chapter is to give you a big high-level overview. It is not my expectation coming out of here that you now all of a sudden know how to do all of this. All right, so we've got 19 and 20, so one person has dozed back off or making breakfast or I'm not sure what, but let me share these results, which are heartening, certainly. So the vast majority say it's about what I expected. Let's get on with it. Total surprise, but looking forward to it. There are a couple people who are a little shocked, and that's why I asked to get a feel for it, and it is expected. And I just want to reassure you, if you're one of these shocked and frightened people, to any degree, to whatever degree, we will go back into everything that's important, go over it in more detail, have activities, have homework. By the end of the semester, if you look back at this chapter, it's a funny thing to do. It'll read so differently if you're one of these people who are shocked and frightened, because it'll all of a sudden make sense. I don't think there's anything in today's chapter that at the end of the semester you wouldn't look at and say, well, yeah, of course that's how you do it. That's exactly the right way. I understand it. We are starting chapter 3, object orientation. I mean, if you haven't done object-oriented programming before, it's just kind of useful a foundation to roll into it before you're kind of expected to try out all these different syntaxes. So the goal of this chapter is to show you a variety of different syntaxes that are used to work with objects in Java, and also we're gonna write our first little program. You should know Java is deeply object-oriented. I think I've said this already, but everything in Java is driven by this desire to make everything an object, to use classes, make everything an object, and to work with everything as if it were an object. So much so that even the program that we write, when it runs, is itself an object to the Java virtual machine. So you can't escape the object orientation, even if you wanted to. Here's the hello, the long version of the hello world app is actually a demonstration of object orientation. Objects come from classes, so the app that we wrote starts out on line 1 with public class hello, if you look. That means that capital H hello is a class, and what that means is when Java runs that app, it's going to create an object based on the hello class. It does that explicitly here in line 3, hello app equals new hello. What that does is create an object named app that is running in the virtual machine, and then we can address our app as it runs using that handle or that identifier app. Technically, even hello world is an object. It's a string object. So any Java code you look at, once you start to get used to it, you'll start being able to see the objects, inside of it. In addition, and maybe more obviously, all of the widgets, everything on the UI, everything you're going to build, your cool little apps out of, will come from Java classes that have defined those UI items or that you've modified to change them in some way that you want. All of the widgets we use are built into what's called the Swing library. It's not the original Java library. It's sort of the version 2 Java library that's handles multi-threading and various other things better than the original one did. But that's where we get all these J's. I don't know if you're looking at the screen and you can see there's JToolbar, JFrame, JButton, JTabPane, JScrollPanes, blah, 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 blah. It's a lot of J's. Obviously, J just stands for Java, but you might reasonably think, well, why put the J there? We're programming in Java. Isn't that, do we really need to say that? And so the reason is just this historical situation that all the original interface elements didn't have the J's. So there were frames, there were labels, there were checkboxes, there were buttons without the J. And so these Swing versions are the better replacement ones. You cannot build a Java app without creating objects. You cannot create a user interface without using even more Java objects. Objects are great. We like objects. You're probably sold on objects. You're already thinking, how do I get an object? I want more. We don't code objects. When you sit down at Eclipse and start writing code, what we're coding is the definition of an object. And so it's kind of like a blueprint or a very detailed plan for constructing something. So when we need objects of a certain type, we first have to step back if we're creating our own classes and write the class, or if we want objects of a certain type and it's based on a class that's built into Java, we need to figure out what the name of that class is so that we can call it and create objects from it. The process of creating an object from a class is called instantiation. So you instantiate objects from their class. What we actually code is the class, and then we use the new statement to create objects from that class to create the functionality, behavior, and appearance that we want in our app. There's thousands of built-in classes. In addition to that, you can create your own classes. So in business is a pretty common need. We'll need to create classes to describe things in our business like customers, employees, items, suppliers, transactions, reports, and so on. Those are not built into Java because there is no universal definition of what a transaction is or what data about customers you want to manage and work with. So these all end up being classes that business programmers end up needing to build to create apps that will support their particular business. There is another commonality in the syntax that you might have noticed, or certainly in prior languages that you've noticed, but it's maybe even a little bit more extreme in Java, in that we use braces and brackets and other symbols, and they always come in pairs. So there's a symbol that opens or starts something, and then there's a symbol that closes or stops something. And so even if we look at this tiny version of Hello World, which is all I could fit on this slide, you see a lot of matched pairs. So it's easiest to see the ones that are right next to each other, right? So after the class name string, you can see that there's an open and closed square bracket. Easy to see because they're right next to each other. You might also notice the quotes around Hello World. They're separated a little bit, but they're still you can clearly see what they're encircling. So the quote means start the string literal here. The second one means stop the string literal here. You might also see the parentheses. There are a few parentheses. These here are opening the parameter section for this main method. So it opens it and it says this method will take this parameter and then closes it to say and no more parameters. The system out print line has the same basic parentheses, except we're using a method. We're using the print line method and we're sending it something. So between those parentheses is the actual data we're sending to the method, which is the literal hello world. Then obviously the curly braces, right? So you see after the class name hello, there's an open curly brace, but now it gets a little confusing because where's the closed one? There has to be a closed one. If you've opened a curly brace, you have to close it somewhere, and it defines the contents of whatever you've opened, the end of the contents for whatever you've opened. So for the class name, we open the class contents. Everything after this is part of the class. So we'll close the class contents typically at the very end of the program. So the matching brace for the first open brace, the matching close brace is way down here. The main method has the same thing. The open brace here identifies the start of the code, the block of code maybe that's inside of the main method. In this case, there's just one line of code, but that's pretty atypical. Most methods will have lots of lines of code. And there's the close to close the main method. So this says, and that's the end of the contents of the main method. So you can also see that indentation helps. You can line up the close braces, hopefully with something that was started and opened with an open brace. They should line up, ideally they should line up vertically. Eclipse will do that for you as you type. However, it can get confused. It will sometimes definitely get confused about what you're trying to type, and it can get confused when you paste stuff in from different places and maybe don't capture all of the correct open and close symbols. So there are certainly ways that you can create code that is missing one of these matched pairs and or is not able to be lined up like this by Eclipse at least before you add the missing symbol. Anyway, this will be one of the things we make mistakes about all semester probably will be, oh, I forgot to close the parenthesis, or oh, I forgot to close the curly brace. So we're moving on to the syntax for creating objects. I've already mentioned this, but the syntax is to use the new keyword. So new is a reserved word in Java. Let me highlight it on screen, but it's there. New is the keyword that triggers instantiation. So if I have a need for an object of a particular class type, I'm going to use this syntax that involves the name of the class, some valid object identifier that I want to call this, and then the equal sign and the new syntax. And new is followed by the class name again, parentheses that may be empty or not empty, and then the semicolon typically. So as an example, since that's so generic as to be almost not helpful, if we wanted to create a new JButton and we wanted to call it B, which is a perfectly good name if there's only one button. If there are multiple buttons, you won't want to call them B. You'll want to call them something like OK button or next button or cancel button or whatever makes sense for your code. But B's fine. B's fine here. So the syntax is just JButton B equals new JButton. That will, in Java, create a JButton. It will not do anything with it. It won't be in the UI because we haven't put it in the UI, but it will create a JButton object that we can then add to the user interface, which still won't do much because we haven't hooked it up to a listener, which we cover in chapter 4. But we're getting there. We're going to get an app today with a button. If you can follow along, you'll have one too. Configuring objects again. You use the syntax is to use the name of the object, the identifier. So in this case, we called the button B. In the prior example, we set up the button just by saying new JButton, open, close parenthesis with nothing in it. That'll create a button, but it'll be a really narrow button with no text on it because we didn't specify any text to put on the button label. So that's bad form. Normally we will not create buttons like this with no text in here. We'll put the text that we want to appear on the button inside these parentheses here. But I didn't do that. I didn't do it on purpose so that I could show you how to address the button and do something with it. So if you decide after the fact, I want to put this text on the button, or maybe you're changing the text on a button based on what's going on, otherwise in the UI. So it's easy to change the text on a button. There's a method that's built into JButton objects called setText. And all you do is pass it in parentheses, the text that you want to appear on the button. So b.setText OK will add the word OK to the button label. And as a result, typically widen the label so it's wide enough to fully show the label that you've put on it. All right, so at some point people start to think, oh, wait a minute, he said there's over 4,000 classes. Each class has dozens of methods. How do I have to memorize all of these methods? Or every time I do something, am I going to have to grab a reference book or get to the Java documentation on Oracle's website to figure out what methods are available? You know, in the old days, maybe, but that's now kind of the job of the IDEs. Any IDE that you pick, Eclipse is what we're using, you know, in class, but all of them will do this. They will offer to autocomplete any methods that make sense for the statement that you're typing. And I'll show you that in just a second when we actually type this in. Typically, in most IDEs, you type the name of the method and then the dot, the period. And then after a slight delay, if you hesitate at all, the IDEs will jump in and assume that you're confused and offer you the 20 options that you could continue with at this point that would make sense given what you're coding. You don't really have to remember if this method was called setText. You know, in some other languages it's setLabel or something like that. If you're not sure, you can just pause after the period and get all of the methods. And then if you start typing, like you type set, then you're not sure if was it setText or setLabel. If you type set, then you'll get a narrowed down list just of all the set methods that make sense for the code, for the line of code that you're writing, which then typically you'll scan down it very quickly and you'll see, setText, that's what it was. That's what it needs to be. And the other nice thing in Java is this really tremendous consistency. Pretty much any widget that has text can have the text changed using the method setText. So once you know that and know that Java is super consistent, almost always you'll already know the method that you need to call. Even if you've never called it on this widget before, you'll know, hey, it's probably setText. That's what I'll use. You can see in the screenshot, I've created this JButton, and then I want to do something with it. So I say b dot, and then I pause, and we'll get this rather large list. I'm going to slide Eclipse on screen here. I'm going to close out the app that we were working on. And so for most of the stuff I do in class, I'm going to, I've already set up my workspace, but I need to create probably a new project folder for the chapter that we're in. So I have a chapter 1 folder, and the hello app was the one that was from chapter 1, but we kept working on it and doing stuff in it in chapter 2. That's why there's no chapter 2 folder. But so if I want to create a new project, I'll use the new Java project option. You can pull that down from the file menu. You can right click in the package explorer. I think there's also a keyboard shortcut, and if you want to, you can also add that button to your toolbar. But I'm just going to call this new project, chapter 3. And everything else I'm going to leave default. I'm not going to create a module. So if you're following along, do not create a module. In Eclipse at least, that will screw up the Eclipse project. And now I've got this new project. There's nothing in it, so I want to create an app. Chapter 3 has us doing an app with a button, and then a text field and a slider later. But let's get the button going. So I need a new Java class, so I can use the new Java class button, or I can right click on the source folder and say new class, or I can grab the file menu and do the same thing. That will launch this second wizard, which is asking you for the name of the class. So I'm just going to call this demo 1. Okay, so you'll see if you're trying to follow along, you'll see that there's a new editor file, a new Java source code file called demo1.java that was created. It's called demo1.java because I named the class demo1. So you can see that there's a match between the name of the class and the file, and you have to have that for it to work. All Java apps will have a main method, one main method. And so this always has the same syntax, public static void main string, just type that, string, open, close square braces, and then to make it piratey, I'm going to say args, open curly brace, close curly brace. This line has to be exactly like this. The only discretion you have is this parameter name. So if you're not feeling that piratey, use less R's. If you're not pirate at all, then don't use arg. You can use parameter or param or anything. Has to be a valid Java identifier is the only restriction there. We will, in most cases, in our GUI apps, take a couple of extra steps. One will be we're going to create a method called demo1. In this case, it will be named after the class. So I do that first so that you can still see there's this consistency. There's demo1 is the name of the class, demo1.java is the name of the source code file, and demo1 is the name of this constructor method is what it's called. It's the method that will be called when Java instantiates the app based on the demo1 class. We're going to explicitly create the app object by saying class name demo1 app equals new demo1. So that line of code, what's now on line 5, creates a named app that we can address using the identifier app. So if you're following along, obviously if you have any trouble, raise your hand or jump in. But what you've got here is the basic outline for a lot of the programs that we're going to write. It's absent a few key things. One of them is if we're going to make it a GUI app, that is if we want a window to appear on screen, the way in Java to do that, or a way of Java to do that is to make the app a windowed app. And you do that by using the keyword extends and then the class name JFrame. Sorry, let me zoom in on yeah. If you're trying to follow along and see, is that large enough for everybody who wants to be able to see what I'm typing?
I have a question really fast.
Shoot.
How would, I know last year in Lua and in Microsoft Visual Basic, there's a way you can insert comments. So if I just want to type know what I'm doing.
Exactly, and that's a great tip. So in Java, a single line comment is //.
Okay, awesome, thank you.
And you can see everything you type will then be in this particular kind of pea green color. You can change the color styles in Eclipse, but you'll start to get used to the colors, and you'll know then, hey, I must have mistyped something because I thought I was typing a comment, but it's not pea green. And you'll realize, oh, I forgot, I only typed one // or whatever the case may be. You'll start to get used to what shows up as green, what shows up as brown, what shows up as this purple, and so on.
Awesome, thank you so much.
All right. Okay, but nobody's mentioned, I assume out of kindness, and I wish not to embarrass me, nobody's mentioned that there's an error on screen screaming at us. You'll see the class name JFrame is underlined in red. If we hover over it, you will see JFrame cannot be resolved to a type, which is a frustrating little error because JFrame is built into Java. It's not a custom class, and yet the Java program can't find it. So it's just a quirk of Java that you either have to fully type out the location of the JFrame class inside of the runtime environment, which will involve knowing what folder it's in, what subfolder it's in, and so on, or you import that folder as a shortcut, essentially, inside of this app so that you don't have to type out the full address of JFrame. So you can see the first quick fix here, if you're following along, is import JFrame. So that's the one we want. And so you'll see at the top of the code it says import javax.swing.jframe. That tells the compiler now where to find JFrame. The thing is, every time we type lines of code that use new classes in Java, in Eclipse or NetBeans or whatever, it's going to come up with this, wait a minute, where is that? And you'll need to re-import your, or reorganize your imports. Let me see if I can show you how to do that real quick. One of these menus is source. There it is. So it's in the Mac at least, there's the Apple menu, the Eclipse menu, the file and the edit menu, and then there's the source menu. And if you select down, you'll see organize imports as one of the options. So it's also got a keyboard shortcut, which is Shift-Command-O on the Mac, and it's something like Shift-Control-O or Shift-Alt-O on Windows. You'll just need to pull that menu down and look at what the shortcut is, because you can either do that every time you need to get one of these errors to go away, or you can learn the keyboard shortcut and just as you type, you can hit that combination and get the imports fixed. All right, let me jump back to the example just to show you where we're going. So I'm trying to create an example where we're going to see this pop-up menu. So that is a JButton. So I'm going to try to create. I cannot select. All right. Okay, so I want a JButton. The syntax to create a new object is class name, JButton. I'm calling it B just because I'm lazy, equals keyword new, class name again, semicolon. That creates a new object B, which is a JButton. If I move down into the constructor, which is where we'll set up and configure our objects, now I want to add that text, just like in the book, just like in the keynote. So I'm going to say B dot, but then I'm going to pause because I can't remember. Was it set label? Was it set text? Was it something else? So as you might notice, pretty quickly after I paused, I get this drop down that's the screenshot is in the keynote. And there's a lot of stuff. So you can start scrolling through it to get a feel for all the different things we could do with JButtons. Or if you know, I really want to do a set method, you could type SET, and that'll narrow the list down to methods that have the word set in it. Or maybe you don't remember it's set. You could type text. That'll be the same thing with text. I don't know which is more helpful. I normally just type set, and then I look to see if there's a set text. There is a set text. Okay, that should do it. So this is a valid Java program, so let me run it. If you're following along, you can run it by hitting the Run button. It did run. If you're watching really closely, at least on your system, on my system, a little app showed up in my dock at the bottom and then immediately disappeared. So the reason is the app doesn't do anything. It creates an object, but doesn't use it in any way. So Java starts up, it creates the button, and then sees there's no more work to do, and so it quits, it exits, which is not what we want. So what we want to do is put the button in a UI. So the syntax just to add a button to your interface is the method add, and then the name of the object you want to add. Let's run that just so that you get a sense of, oh yeah, so that still doesn't work. And I apologize, I'm a little rusty. I'm used to Lua at this point, but I'll get more and more used to Java again. There's a weird default in Java that JFrames, which is what we're creating a windowed app. By default, they're invisible. That's another one of these things today. I feel like I should apologize for that because it doesn't totally make sense. But it's not my fault. And it's just something you have to remember. So if you run your app and you're looking at it and you think, I have everything. Where's the JFrame? Where's the window? Remember up here in the main method, we're typically going to do a couple more things. One of which is we're going to say app.setVisible true. That will render the window visible on screen. So let's run it and see what we get. It's still not going to look good. All right. If you're doing it, at least on my screen, it showed up in the upper left-hand corner as this tiny window with just the three decorations on it. The reason is, in addition to being invisible, default windows based on the JFrame class are also sized at 0, 0. They have no area. So what you'll notice is you can't actually drag this, if you do it right. You can, all right. Oh, it started. There we go. If you drag it out, you should see your button there. But that is annoying. We do really not want to have to make the user do that. So we will typically size the window as well. We'll say, in the main method, we'll say app.setSize. And you could say 100 pixels wide by 40 pixels tall, something like that. This will also depend on your screen and whether you have a really high resolution window screen or not. But you just have to play around with the pixel values to get a size that you like for each app. So that wasn't great. I need that to be taller. So I'm going to say, for me at least, for my high resolution screen, I'm going to say 200 by, well, let's just make it 100. Nothing fancy. So your numbers here will just vary based on how big you want it and the resolution of your screen. All right, if you look down at the bottom of the screen, there's one more annoyance. That's that I can't move. Oh, come on. You should now be able to see the bottom of my screen, my dock. And if you look down at your dock on a Mac, you'll see the same kind of thing, which is multiple Dukes giving us the thumb up. So it's an optimistic little icon, but what on earth is it? These are 3 running Java programs. They don't have icons because we didn't set an icon, so they get the Duke thumbs up icon. Now, depending on the version of Java you downloaded and installed, you might get a different default icon. You might see a coffee cup. You might see something else, or a variation on the Duke icon. They change it up. In any case, why on earth are they there? We're not running any apps. If we jump back to Eclipse, well, you can quit them. First off, if they're there and they're annoying you, you can, on the Mac, you can right click and say quit. I assume there's I can't remember. It'll be, well, so on Windows you won't see that. Sorry, yeah, I was trying to think of the Windows approach to doing that, but on Windows you won't see those accumulating at the bottom of the screen. So a little bit of just Mac Windows history, or UI differences. People think, oh, they're just become so similar that you can't tell them apart. They do the same thing, blah blah blah. There are a few differences. I mean, the Apple menu is one difference on Macs. The other is that Mac apps expect to be multi-windowed. That's the default. So when you launch or create an app on the Mac, it expects that it's going to have more than one window on screen, and that just closing the window won't necessarily quit the app. If you have, for instance, multiple windows open in Microsoft Word on the Mac, you wouldn't want, if you closed one of those windows, for the whole app to quit. So same thing here. When you close a window, it does not by default quit the app, which it does on Windows. So you won't get that accumulation of stuff down in your taskbar in Windows like we will get it in our dock. So the fix is super easy. I'm still up in the main method here, and I'm going to try to, it doesn't want me to type. So I'm going to say app dot. The method that we want to call is a really long one. You don't want to have to type it. It's set default close operation. But if you type set D, then the top hit is set default close operation. And then we can pick from the list, we want exit on close. That will make this app work like a typical Windows app. Anyway, to run this again, here's the OK button. Let me move this so that you can see my dock too. Okay. So here's the OK button. There's the app that's in my, my dock. I can hit OK all day if I want to. It doesn't do anything. But if I close it now, what you'll see is the dock icon disappears. So it did quit the app completely. We've pretty much covered a lot of this. So we've just created an app that added the button. The next thing we add to this demonstration is a text field. This will form kind of the first easy app that we'll work on in Chapter 4 to make it work. We'll make it count by clicking the button. So when you click the button, it'll count up by 1 and display the result in the text field. So it's a really simple little app that uses UI setup and several Java classes and obviously math and lots of object-oriented syntax. But anyway, if you look at this screenshot here, what you can see is you see right away, hey, visually, I know there's 3 Java classes I need. I need JFrame because it's a windowed app. I need JButton because I can see the button. And I need a text field, but what's the text field called? Well, you could probably guess if you weren't sure, but it is in fact JTextField. The only thing that will throw people sometimes is, for instance, is the T capitalized or is the F capitalized in text field? Is the T capitalized? Is the J capitalized? And that's where just a little bit of typing experience and autocomplete can be helpful. There may be other objects that we'll need to use in our apps, but visually, just by looking at the UI, you can identify, hey, there's several. So we want to code this app. You could probably code it yourself, except there's a couple things that'll throw you about Java. So step by step, what we're going to do is we're going to create the app with the empty window, which is a JFrame. We're going to add something called a panel, which holds multiple objects. We'll add the button to the panel, and we'll add the text field to the panel. So in that order, that will create the app that you see on screen. So I've got it broken down as step by step in the keynote. I don't know that we'll get through it all, but we should get a really good start on it. If you want to also, I mean, you can sit back and watch me do it, but if you're at your computer and you have Eclipse up and you want to follow along, that is kind of the intent here, is for you to be able to follow along. Or if you want to follow along and, maybe I start going too fast or you get stuck on something, you can always go back and follow these steps. All of the keynote slides are available in the Course Access Hub as PDF files with every single slide, in there. As a starting point, step 1, we create an app which extends JFrame, and we do the basic stuff that I just said you need to do for apps. We have the app instantiation with the new statement, we have the set size, and we have the set visible. So if you're following along in Eclipse, you could also, well, if you have the PDF version, you can select all of this text inside this table. I'm having trouble doing it with the screen sharing on, but if you want to, you can highlight all this code, select it, and then paste it in Eclipse. So you want to paste it on a package, which I can't type, I can't select. All right, you'll want to highlight the package and then right-click and say paste. Eclipse is actually smart enough to take it off the clipboard, identify the name of the class, create a file to edit with that class name, and then paste your code into it. You will notice that, let me zoom in, you might notice, if you're following along or if you're just watching, that there's a lot of red. This all stems from the fact that we haven't imported JFrame, so it doesn't know the set size method or the set visible method. So all of these are directly driven by the fact that we haven't imported JFrame. So you can do it however you want. I'm going to do Shift Command O, okay, which made all the stuff disappear. That is step 1. Step 2, if you're following along, is to create this constructor method and the panel, and add the panel to the UI. So let me jump I'm just going to type this now because cutting and pasting is kind of awkward with the screen sharing going. So I want a panel. The class to get panels in is called JPanel, capital J, capital P. I'm going to call it P as my identifier. Not a great name. If I was to have multiple panels, I would want to give each panel a descriptive name. So for instance, if I was putting buttons on the panel, I might call it button panel, you know, or settings panel, or whatever makes sense given what I'm going to put on the panel. We've got the red back, which means we need to reorganize imports. And then I need the constructor method. So you might also notice that my indentation screwed up. So the indentation I used in the keynote was scrunched to make everything fit, which is a common need. But then that means when I paste it into Eclipse, it's got spaces instead of tabs and too few of them. You can always go back and reorganize your code, and I'll show you how to do that in just a second. But let's do the constructor method. The constructor method uses the class name using objects, open close parenthesis, open curly brace. To get step 2 done, I just need to add P. So this will run. This will create an app with an empty window. It's on the keynote as well. So that is a 200 pixel by 60 pixel window here. Nothing's on it because we haven't put anything on the panel, so that's the next step. If you're on a Mac and you close it, that will obviously not actually close it, so I'm going to finish up the Mac setup. Move to the next slide. So step 3 is to add the button, and then add the button to the panel. And you can guess that step 4 is going to be to create the text field and add the text field to the panel, but let's just do it so that you don't have to imagine. So if I want a button, and I want to use kind of lazy identifiers, I'll say JPanel, sorry, JButton, B equals new, JButton. You can call it whatever you want. I guess in the keynote I say click here. When we add functionality, it's going to be counting functionality, so you could also say count or add 1 or something like that. I need to reorganize imports again. So if you're getting used to doing that, it's just the quick keyboard shortcut. And then I need to add the button to the panel. I want to add the button to the panel, and typically I want to do that before I do anything with the panel on screen. So the syntax to add something to a panel is panel identifier, which is P in this case, dot add component B. So the way to read that is just p.add b, which says put the button on the panel, put the panel in the JFrame. That will create the app version you can see in the keynote, which is a window with click here in it. Let's jump to step 4. You can see I need to add the text field. The class name is JTextField. You call it whatever you want. I call it TF here just to keep things short. And you can set the width and characters that are visible in the text field by putting the number here. So just jumping back to Eclipse, I want JTextField. TF equals new JTextField 3. All right, so a couple things. First off, the indentation is now really annoyingly bad, and I have the import issue, so I'm going to reorganize imports using the keyboard shortcut, but then I'm also going to look at the source menu again. There is an option in the source menu, if you pull your source menu down, that says format, so source format. If you do that, it will correct the indentation for what's on screen. So I just selected that, and you can see Eclipse has run through it and corrected the tabbing and the spacing to make it look correct. Okay, so I need to add the text field to the UI. So the syntax is p.add tf. So I've created a JPanel P, I created a JButton B, I created a JTextField TF, and I added each of them to the panel, and then I added the two widgets to the panel, then I added the panel to the UI. So it does not want to run because it's not getting the click. All right. Here's the app. Screenshot of that is in step 3 on the keynote. Obviously this doesn't do anything. Sorry, that was step 4 on the keynote. You can hit click here, nothing happens. You can type in the text field, but nothing's happening because although we've created this UI. Sorry, trying to move my. Come on. Yeah, so again on the Mac, if you're using the Mac, we use the setDefaultCloseOperation, which is in the Keynote Live. I think just looking at where we're at time-wise, we're down to slide 21 in this chapter. There's only 29 slides, so we will start Tuesday here on slide 21, flow of execution. So we're still a little behind. We will finish up chapter 3 next time and start chapter 4 next time. Chapter 4, just to entice you, will be how do we actually make that app do anything? If we want it to count, how do we do that? How do we make the button actually work? Where do we put the code that does the counting? What's the syntax for updating the value in the text field and so on? That will all be revealed to you in chapter 4. There is obviously a quiz, little easy quiz for today. I did make it. I mean, in terms of timing, I realized I really want to trying to get into a rhythm, and it's just different than the face-to-face semester. Normally, in a face-to-face semester, as soon as we're done with class, I run back to my office and enter all of these doubloons because we've done in-class activities and we've done team activities, and everybody's earned a different number, and I've got to go through my list and notes and tally everything up while it's fresh in my memory. The online class, that just doesn't make sense at this point. So you guys are doing this little quiz, but there's no reason for me to make it due immediately. My goal is for you to be caught up before the next class period. So right now, at least for right now, the Tuesday quizzes will be due Thursday before class to give you that flexibility anytime from Tuesday, Wednesday, Thursday before class to have done to have watched the keynote live if you missed it and do the quiz. But so on these Thursday ones, there's no reason for me to make it 24 hours or even 48 hours. I'm just going to make it due before the next class and see how that works. So you'll notice on this quiz, it's not due until Tuesday at 10 a.m. Doesn't mean you have to wait until Tuesday at 9:55 to take it, but you could if you wanted to. I'm done. That's all the material that we're covering for today.